Good morning, one and all. So, for this month lecture video, I will start with the topic called as IPC, that is Interprocess Communication. What is actually the definition is IPC, it's mainly acts for the communication in the which has to be done in the operating system. So, which plays a vital role when each process wants to communicate with themselves. Say, for example, if you have process 0 and process 1, if they want to share some variable, or if they want to share a memory, or they have to do some read or write operation, we need a concept called as interprocess communication. So that's what the definition goes like this: different processes to communicate and cooperate with each other. IPC, which comes under a cooperating process. Okay. So it is actually crucial for multitasking. Why it is crucial in the sense, we need when it comes as multitasking, we need to synchronize first. We need to synchronize all the system that are all interconnected in multitasking, and we need to collaborate it effectively. So what is actually the need for IPC? Why we need IPC is, I already told, we need to share data, synchronization, communication, and resource sharing. Data sharing means process often can have the opportunity to share data, and synchronization means process may need to synchronize their activities. Communication, process might need communicate for a variety of purposes, for exchanging information, for signaling, or to error handling. And resource sharing, IPC, mainly the work of IPC to help or to manage and share resources. Say, for example, it may be file access or memory or hardware devices among process. Next is IPC methods. We have two models. One is message passing and shared memory. What is actually done in message passing is, processes will exchange data by sending and receiving messages through a messaging system. So this method is particularly useful for IPC distributed system. And next comes is your shared memory. Shared memory is two processes can share the same memory. There will be a common shared region. This method is efficient, but it requires synchronization mechanism to avoid data inconsistency. And the last method is sockets. Sockets, normally it is used in the network system. Process can communicate over a network or on the same machine by reading and writing data through sockets. Next comes is the threads. Thread, we know the definition of process. Thread is nothing but it is the lightweight process, we can say. So the idea behind thread is, we need to achieve parallelism by dividing a process into multiple threads. Say, for example, you have a real-time example, as you have a browser with multiple tabs which can be act as a different threads. So MS Word uses multiple threads, one thread to format the text, another to process inputs. Threads in OS. So this is the diagram of threads. The whole thread is circle, circle is process. Inside process, the small lightweight process, we can say it as threads. As how the process is having ID, program counter, register, stack, etc. The same way, threads also have what? Thread ID, program counter, register, and stack. So here is the difference between single thread and multi-thread. Uh, yes, the left side is meant for single and the right side is meant for multiple threads. What is the need of thread actually? Comparing to process, it will take less time to create a new thread in an existing process than to create a. So instead of creating new process, we can create new thread. So threads can share the common data. They do not need to use interprocess communication. Whereas if it is process, it has to use IPC for communicate. It takes less time to terminate a thread than a process. So creating and terminating a thread is far easy compared to process. Thank you.